point 1 on this one here. Okay, what is meant by the word acceleration? Well, acceleration is the change in velocity per second. So as an example, imagine 1 second I'm moving 4 meters per second, and a second later I'm moving 10 meters per second. The change in velocity would be 6 meters per second. But because that happened within a second, it's called 6 ms squared, okay? So a way of defining acceleration is by just looking at this here. And we see on page 293, basically the acceleration chapter. Acceleration of an object is the change in velocity of that object per second. Okay, so that's our first answer there. It's the change, there we go, we'll just put it there. It's the change of an acceleration object is the change in velocity per second. Next one, name a famous scientist who discovered gravity. So Isaac Newton, and it's just Isaac Newton, yeah, that's it, done. All right, 31.2. For the balance forces in figure 31.1 of your workbook, what will be the effect of balance forces on the motion of an object? Okay, let's have a look. So it's obviously on the next page here. All right. So in general, guys, balance forces is when, for example, if I have a force pushing to the right, like so, and then I have a force pushing to the left. Okay, now if it's balanced, let's say I push this block 50 newtons to the right, but it's also balanced by 50 newtons to the left. Basically, there will be no acceleration. This block will not be accelerating because the forces are balanced. Or you could also say there will be no change in velocity. If it's traveling at 50 kilometers an hour, it will stay at 50 kilometers an hour. If it's traveling at 0 kilometers an hour, it will stay at 0 kilometers an hour. What will the effect of unbalanced forces be on the motion of an object? Well, very simply, if I change that 50 to a 70 newtons, pushing to the right, 50 newtons to the left, that'll be 20 newtons to the right. This means that there will be an acceleration, or there will be a change in velocity. A change of velocity. Okay, the change of velocity can be up or down depending on, you could be slowing down or you could be speeding up, depends on the situation. Okay, 31.3. A parachutist jumps from a plane. The force of gravity pulls him towards Earth. However, as his speed increases, air resistance acts against him more and more. In terms of the force, why does the parachutist accelerate for the first 30 seconds of his descent? Well, if you imagine a skydiver by this stick man here, we'll put his arms going out in front, and he's descending down. So we'll do 2 arrows. We'll do the force of gravity, which is his weight, as the black arrow. Okay, so let's say for argument's sake his weight is, if he's 80 kilograms, his weight will be 800 newtons. Now imagine at the very beginning, you're not moving that fast. So air resistance, which I'll depict by this green line here, is smaller. So let's say for argument's sake the air resistance is only 50 newtons. This means you're going to accelerate downwards with a force of 750 newtons. However, as you start to go faster and faster and faster, what will happen is your air resistance will get bigger, and eventually your air resistance will equal the weight. So therefore the green arrow now balances out the black arrow, so the forces are equal and there will be no more acceleration. This is known as terminal velocity, where the skydiver remains at the same velocity, because he's no longer accelerating, because the forces down equals the forces up, because his weight is a larger force than the air resistance. Now, After 30 seconds, the parachutist reaches a constant velocity. A. He does not accelerate any further. What can you say about the forces acting on his body? The forces are balanced. Air resistance equals his weight. Okay, everybody cool with that? Alright, let's move on. After 40 seconds, the parachutist pulls his parachute cord and the parachute opens. This greatly increases air resistance. Draw a diagram to show the forces acting on the man and what effect will he have experienced. So, it's the same man as the last picture. He has a weight of 800 newtons. Okay? All of a sudden you have a parachute. This parachute means your air resistance is now a lot higher than it would have been otherwise. So we can put an A value of, let's for argument's sake, A is a much bigger line now. So we can say A is, let's go for 2000. I'm just making up a number that's bigger than 800. Okay. If you have 2000 newtons up, 800 newtons down, this means that overall you're going 1200 newtons upwards. This will cause a deceleration because your person is currently moving down the screen, but if you're accelerating him, he'll be moving down, but then he'll start to slow down because it's a deceleration because the force is in the opposite direction to the parachutist's motion. He's meant to be going down, but the net force is going up. It's going to slow him down. It will slow down his velocity. If the parachute is slowing down, what can be said about the forces acting on him? The force is up. The air resistance is larger. The air resistance is a larger force than his weight. Larger force than his weight. Is that okay? Now, give a practical method for reducing friction on the following. Squeaky bicycle chain, you can just put oil on it. Okay? Put oil on the chain. Okay. Jet moving through air. Reducing friction, you need to do air streaming or aerodynamics. Air streaming the design of the plane. Okay, I think there's something about that in the book actually. I think if we go backwards here. Ways of reducing friction. I think it's top of page 309. No, maybe it's top of 304. Streamlining. So you can, streamlining. Sorry, streamlining was the word I was looking for. Or aerodynamics. Okay, heavy sack drag on the ground. I don't know, use a shopping trolley or wheels. Sorry, put it on a shopping trolley. Should be put the sack in the shopping trolley. A shopping trolley. Stiff roller skates. Grease the ball bearings. So sometimes the ball bearings get dirt and grit in it, so it's important to grease them. Boat traveling in water, once again streamlining its design. Streamlining the boat's design to reduce water resistance. To reduce water resistance. Okay, let's keep going. Okay, now Again, introduce the measures first. Well, this here is a spring balance. Please make sure you watch my video I attached to this assignment, because it will help you understand how to use the spring balance. What force acts against the motion of the block? Well, that's going to be friction. Friction opposes the motion of the block. How could this force be reduced? By lubricating the table. Lubricating the table or trying to make it smoother. Or try to make the table smoother. You can make the table smoother by varnishing it, stuff like that. I think it said smother. Need to look up smoother. Turns out I did spell it right. Look guys, you always gotta check these things. Otherwise, you never know if you're right or wrong. Okay, next part. What is meant by the weight of a body? Now this is often a pretty hard, difficult question. What is meant by the weight of a body? Well, what we can do here is, once again, we just go to our book here. We just go to weight. There it is there. And then we just go upwards. Oh, it says, what is weight? The weight of an object is the measure of the force of gravity on it. Okay, it's a great thing. So the weight of an object is the measure of the force of gravity on it. Okay, there we go. Awesome. There's the answer for part A. Now part B. Give two variables that affect the weight of the body. Well, I think it's the mass of the body and basically what the gravity of the planet you're on is. But look, we'll have a look at that as well. So there's another part here. We go over here. It's factors that affect your weight. So let me see. Back again. Okay, it depends on the amount of gravity in that location, and it can't be zero. Okay. Depends on the gravity at that location. And the mass of the body. Depends on the mass of the body. Okay, a neutron star is formed when a massive star collapses in on itself. It has approximate mass of our solar system concentrated in a sphere that is 10 kilometers diameter. How do you think the weight of a body would be affected if it was brought close to a neutron star? Well, neutron star has massive gravity. So if you were standing on the surface of a neutron star, you wouldn't be able to stand, you wouldn't be able to leave it because the gravity would be too strong. So the weight of the body would drastically increase. Would drastically increase. Give a reason for your answer. A neutron star is extraordinary. Sorry, a neutron star has an extraordinary level of mass. Extraordinary. I always spell that one wrong. Extraordinary amount of mass. In a concentrated sphere. This gives it a huge amount of gravity. This gives a neutron star a large amount of gravity when close to it. Okay, larger gravity equals larger weight. Larger value of gravity means a larger weight. Okay, guys. All right, let's keep going. So we have basically we're given the value of gravity on each of the following planets, which is all these ones, and the mass of the man is 70 kilograms. So no matter what planet you're on, you're always going to be 70 kilograms, unless you happen to like do lots of exercise and you decrease the amount of matter in your body. However, the weight is different. To get the weight on the moon, you multiply 70 by 1.6 and you get 112 newtons. Then it's 70 times 25, 1,750 newtons on Jupiter, which is very large. Okay, close to 3 times that of Earth. Then 9.8. No, you guys use 10 in the junior cert, but in this case we'll use 9.8 times 70, 686 newtons. And 3.8 for Mars, because Mars has less gravity than the Earth. What we get there is 266 newtons. And then finally the Sun, which has an excessive amount of gravity, which means that if you ain't going to escape the surface of the Sun because you weigh 19,180 newtons. Now, a 70 kilogram person normally experiences a weight of 686 newtons. So when you're walking around, when you push off the ground, you have 686 newtons downward. So when your leg muscles have to exert a force bigger than 686 newtons to jump or lift yourself off the ground. If you're on a planet like Jupiter, or I know you can't be on the surface of the Sun, but anything with really, really large masses means you're not going to be able to jump. Just the gravity will be too much. In some cases, you'll squish because your body's not capable of surviving in that environment. Now, Stuart is cycling on his bicycle along level road. The horizontal forces are the driving force and air resistance. These can be shown in the diagram with arrows. The length of the arrows show the amount of force. In figures labelled 31.2 and 31.6, mark the cyclist with the horizontal force that he's experiencing. Label the arrows and name the force. Okay, I'll say D for driving force and A for air resistance. Okay, cyclist starts cycling and begins to speed up. If he begins to speed up, the driving force going to the right will be smaller than the air resistance going to the left. So here we go. D is there. A is a smaller arrow going this way. We'll make D, exaggerate the size of D a bit. There you go. D is a much bigger driving force. Okay. Next one. So what we'll put down is D equals driving force. A equals air resistance. The cyclist cycles along at constant velocity. Well, constant velocity would mean that your D is the same size as your A. Okay, so for me, I can make these two exactly the same size. Just flip it around and somehow change that into an A. So you see both forces are the same because you want the net force. If you're cycling at constant velocity, your net force has to be the same. So if you're cycling 50 newtons of driving force balanced out by 50 newtons of air resistance, means you're not accelerating, which means you're staying at the same speed. Is that okay with you guys? Okay, part C. The cyclist wants to speed up. Cyclist wants to speed up. Now, so if he wants to speed up, like the wants is a weird word. Does he actually start it or not? Okay. Well, look, here's what we'll do. We'll draw an arrow here like so, and we'll just have one of them. They're going to be roughly the same size. Okay. I'm just going to make one of them a tiny bit smaller than the other one. It's not a great question, guys. I wouldn't expect this to turn up on the junior cert, but we're going to make it slightly smaller. And in this case, you're just starting to speed up, because the D value could be like, let's say 60 newtons, and the A value could be 59. So you're just starting to speed up, okay? Could be something like that. Okay. The cyclist is now moving faster but has reached a constant velocity. Well, if he reaches a constant velocity, the D value, which is the driving force, has to equal the A value. So basically these two arrows are meant to be the same size, so they're balanced, okay? And finally, the cyclist is now close to home and wants to slow down. He stops pedaling. So when you stop pedaling, the driving force is non-existent. If you stop pedaling, there is no force on horizontal ground. So it's all air resistance, and this causes them to slow down. Okay guys, that's that question done. Now, give two examples of how friction benefits the cyclist. Well, his shoes can grip the pedals. His shoes can grip the pedals. His tires can grip the road. Can grip the road. Okay, and because you can grip the road, you can move. Do you ever try cycling on pure ice? Very difficult. Give one example of how friction is a disadvantage to the cyclist. It can cause the tires and the brakes to wear out. Cause tires and brakes to wear out. Give three ways in which friction is reduced in a bicycle. Well, you must know the thin tires on a hybrid bike or a racer bike compared to the thick tires of a mountain bike. Thick tires on a mountain bikes are harder to cycle, they aren't as fast. Thin tires are the fastest, right? So thin tires to reduce friction. You can have you need to oil your bike chain. And finally, third thing, the bike could be air streaming or streamlining the bike. So some bikes are streamlined. You see them, they're quite streamlining the bike. Okay, and that can reduce air resistance or air friction. Okay, that's another way of doing it. Yeah, I suppose ball bearings. There's actually ball bearings in the shaft of the bike sometimes as well. So we can also say bearings in the crank. Okay. Give one way in which a cyclist can reduce friction when cycling. Oh, wear streamlined clothes. In some cases, some cyclists shape their legs to reduce air friction, but we won't go into that. Imagine there's lots of hairy legs. You don't really see cyclists with hairy legs. Why is friction important on the pedals? Well, it helps your foot helps your foot apply force. Apply force to turn the pedals. Handlebars ensures the cyclist can steer. Okay. Tire, so the bike can grip the road. Can grip the road. So the bike can slow down for the brakes of it. Okay. Nextly, state of friction is increasing the following: football boots. The jagged edges of the boot increase friction with the ground. Studs increase friction with the ground. I think I might start typing. Starting to get. Now, where was I? Oh yeah, we'll go this way. Okay, car tires. Rubber increases friction between the car and the ground, between the wheels and the ground. Because rubber compounds tend to be quite sticky on the surface. I know they look flat, but there's lots of like little under a microscope you can see that rubber is actually quite jagged in a way, but just not really hard to notice unless you have it under a microscope. Okay, now state of friction is increased on the following items. Icy roads. Well, you put chains on your wheels, put chains on your tires to increase resistance. Or sometimes you salt the roads to melt the ice, or you grit the roads to put grit on the roads to increase the friction of the ice. Once again, very similar to part B, the material, rubber material increases friction with the ball. Snooker cue. To increase friction, I suppose chalk on the tip of the cue increases friction between the cue and the ball. Okay, alright, all good. That's 31.10 done and dusted. Okay, what are we on to now? 31.11. How did the student measure the applied force? Well, he used a spring balance. We can see it here, spring balance. Okay, this here, spring balance. How did the student measure the extension of the spring? Well, quite simply, he used a ruler. Okay, no rocket scientist there. You just get a ruler, and then you measure the initial length of the spring, and then measure it after it extends. Okay, so very simply with a ruler. Just make sure the zero is located at the start of the spring. Okay, next part. I think we're missing a part here. We're on 31.12 now. Figure 31.6 shows Newton meter. It consists of a spiral spring inside a tube. A marker on the spring points to the scale, which is marked off in newtons. When the Newton meter has no mass attached, the pointer points to zero. Use your knowledge of Hooke's law to answer the following questions. What happens to the spring when a force is applied on the end of it? The spring extends. It gets longer. Okay, that's the first part. Now, what is meant by the weight of object? The weight of an object, once again, we go to the very beginning, is the force of gravity acting on the object. Acting on an object. Okay, how does a Newton meter use Hooke's law to find the weight of the object? Well, a Newton meter, the spring will only get bigger for certain weights. So if you imagine this is a spring, very poorly drawn spring, right? Now what happened is this spring will extend. It will get bigger according to how much weight is attached to it. Okay? So the spring will lengthen according to what weight is put on it. Spring will lengthen specific distances. Specific distances according to what weight is put on it. According to what weight or force is causing the extension. Weight or force is causing the extension. The plastic tube will not allow the spring to extend beyond a certain length when a large force applied. How is the benefit to the user? It won't break the spring. Or it won't exceed the elastic limit of the spring, which is a fancy way of saying it won't break the spring. Now, in figure 31.11, plot a graph of the extension increase in length against the weight in the x-axis. Okay, let's see where I put this. Ah, there it is. So here it is here. So they did the experiment using weights, and here is my answers. A weight of 0.4 will give me extension of 2, a weight of 0.8 will give me extension of 4, a 1.2 will give me a 6, a 1.6 will give me 8, a 2.0 will give me 8.5, a 2.4 will give me 8.6. Okay, so I'm going to use these figures to draw my graph. So I need to go from 0 to 2.4 up in 0.4s. Well, this is going to be fun. Well, I count 10 blocks here, so I'm going to go up in 5. So I'm going to have 0.4, 0.8, another 5 could be 1.2, this one could be 1.6, another 5 can be 2, and another 5 can be 2.4. Okay, so there's my weight in newtons. Next thing I have to do is my extension, and I need to go up in between 8 and 9. So 1, 2, 3, 4, that's not going to work, is it? Don't have enough space. So I'm going to have to use my head here. I'm going to go up in 5s as well. So when I go up every 5 blocks, so that's 1, 2, 3, 4, 5, 6, that's 7, and that's 8, and that's 9. Now please remember something here, there is a catch. Because we have 5 blocks, 5 blocks is worth 1. This means 1 block is worth 0.2 because you got to divide 1 by 5. Okay? So that means when you're counting up here, look at this, it's going to be 1.2, 1.4, 1.6, 1.8, 2, 2.2, and 8 will be 8.2, 8.4, 8.6, 8.8, and 9. So you got to be careful when you're drawing out the graph. So the first one is 0 and 0.00, 2 and 0.4. So what's it? A weight of 0.4 and extension of 2. 0.4 and 2 is here. That's 0, 0 there. Okay, next one is 0.8 and 4. There we are there. Next one is 1.2 and 6. 1.2 and 6. Next one will be 1.6. Sorry, 1.2 and 6, 1.6 and 8. Where is 8? 1.6 and 8 is there. Okay, and then next one is going to be 2 and 8.5. 2 and 8.5 is halfway between 8 and 9, so that'd be 2.5 blocks. And then 2.4 and 8.6. 8.6 would be 3 blocks above the 8 line. So we gotta draw this graph here. Well, we can see that it starts off at 0, 0, like so. And it keeps a straight line for the first while, but then all of a sudden the elastic limit gets exceeded and the spring breaks. So this little red part here is where the spring actually breaks. Okay. Use the graph to find out what weight that would produce an extension of 5 centimeters. Now an extension of 5 centimeters we can see here. See the 5 centimeters? Draw a line straight across and then go straight down. I'd say halfway between 0.8 and 1.2, which is 1. Okay, so 1 Newton. Study your graph carefully. The spring balance obeys Hooke's law for the earlier extensions, and then when the spring becomes damaged, it will not appear to do so. Estimate from your graph the weight after the addition of which the law seems no longer apply. Well, I think it started here, and if we go straight down, I think it's 1.6 newtons. Anything after that, it doesn't seem to obey Hooke's law. Okay, 13.14. Give an example of how friction is advantageous to him. Well, his shoes can grip the road. Give a disadvantage to him. Well, his shoes will wear jogging wears his shoes down. Wears down the soles of his shoes. Okay. Nextly, give a difference between weight and mass. Well, weight is a force. Weight is a force, and mass is how much matters in an object. Rewrite and complete the following sentences. The something of a body will change depending on its location. That will be weight. The something of it will not change just by moving it. The mass will not change just by moving it. Yep, it won't change much anyway. And finally, the value of G would experience is given for several locations. Calculate the weight of a 10 kilogram. Alright, what in God's green earth is going on here? Okay, calculate the weight of 10 kilograms. Oh, each of these locations. So 10 kilograms. Multiply everything by 10. 160 newtons, 250 newtons, 98 newtons. Multiply that by 10, you get 38 newtons. Multiply that by 10, you get 2,740 newtons. Done. Why do you think that the weight of object in Jupiter is greater than the weight on Earth? Because Jupiter has a larger value of gravity. Because Jupiter is a much larger planet with a much higher mass. Okay, the weight of the body is less on the moon than Earth because the moon has a smaller value. Oh, sorry, I should say than Earth. The moon has a smaller value of gravity than Earth. Okay, move on. Okay, the multiple choice round. Okay, we see two dogs, the brown dog and the cream dog. Brown dog's pulling with 200 newtons to the east. White dog's pulling 170 newtons to the west. This means it's going to be going east. Answer is A. Okay, next part. The figure shows a student measuring the force needed to pull a wooden block up a ramp. Okay, so you see that it's up a ramp. Okay, now what's the question asked me? Which change would require more force to pull the wooden block up the ramp? Nope. Nope. Sandpaper on the ramp would increase the friction. If you make sandpaper on the ramp, the force of friction would be greater. So we go for D. Sandpaper and glue and sandpaper on the ramp will make the ramp have a higher friction value, which means that it'll take more pulling effort to get it up. Okay. What's the name of the device in figure 31.14 used to measure force? Well, you can call it a Newton meter or spring balance, whichever one you want to go for. Okay. 4. Table shows the extension of a spiral spring when different weights are hung from its end. What is the relationship between the weight attached to the end of the spring and the spring extended? Well, we can see that what happens is for every 1 Newton you put on, it extends 3. See the way it jumps up in 3s? That's because you're only going up in 1s. See the way everything's going up in a 1? Okay, last one goes up by a 5. This means that will go up by 15. The force is proportional to the extension. And no, they are not first cousins. Okay, predict the extension of which a 6 Newton was attached to the spring. So 6 Newtons, where is 6 Newtons? Well, 6 Newtons would be an extra 3 on top of that 15, so it would be 18, which is part C. Question 6. Table 31.4, predict the weight that would cause an extension of 21 centimeters in the spiral springs. Well, 6 Newtons was 18, goes up in 3s, so 7 Newtons would be 21. It's got to be 7 Newtons. Or A. 7. 2 forces are applied to a cart on a flat frictionless surface. The forces are 20 Newtons to the right and 10 Newtons to the left. If the unequal opposing forces are applied to the cart at the same time, what will occur? The cart will move left to right. The cart will move to the right. There you go. They're applied at the same time, so that will be B. Okay, because one force is larger than the other, so it's a net force of 10 Newtons to the right. Okie dokie. Which of the following statements is not true about friction? Friction is a force that opposes motion. That's true. Friction wastes energy. That's true. Friction causes wear. That's true. Friction stops planets colliding with each other. That is completely false. An astronaut brings a carton of juice to the moon. Which of the statement is true? The mass of the carton has changed. That's false. The weight of the carton has changed. That's true. The weight has changed because it's on a different planet. There's no gravity on the moon, so it is weightless. False. There is gravity on the moon. The weight and the mass of the carton have changed. No, the weight has changed, but the mass hasn't, so that's wrong. So it's only B that is true. Okay. What is going on here? Alright, we got something here. Car is moving on the road with a velocity of 50 meters per second. The forces on the car is balanced. Well, that means the velocity can't change. If the forces are balanced, the velocity won't change. False. True. It won't. No. So the answer is B. Point 11. The forces which opposes motion between the two bodies is... The force which opposes motion between two bodies is friction. Yeah, gravity actually attracts it, so just D. Okay, anything that causes an object to change its position or velocity is called a force. A. And finally, which of the following is a disadvantage of friction? That's a disadvantage. That's an advantage. Helps a person to write clearly. That's an advantage. It keeps the runner from slipping. So only A is the only disadvantage. A boy is cycling along a road when he applies the brakes. Which one of the following forces occurs between the brake pads and the wheels? Well, friction. Friction's between the brake pads and the wheels. And we're done, guys. All right. So that took me all of 45 minutes. So hopefully it takes you guys a bit longer.